In this video, I want to have a look at primitive functions. So if we're given the derivative function, we're able to figure out what the original function was, or the primitive function, by reversing the process of differentiation. So our first example asks us to find the primitive of x to the power of 4. So we've got dy dx, our derivative, being equal to x to the power of 4. We could also write this just as y dash. And we're going to reverse that process of differentiation to figure out what y is. So if we were differentiating, we would multiply by the power and then we would reduce the power by 1. So undoing that, we're going to increase the power by 1. So we've got x to the power of 5. And instead of multiplying by that 5, we're going to divide by it. So we could write this as x to the power of 5 over 5, or we could put a 1/5 in front. Either way means the same thing. But the other thing, there's something else that we need to think about. And that's if we had a number on the end here, for example, a plus 10, then this would just disappear when we differentiate and we'd still end up with this x to the power of 4. If we had, say, a minus 2, we would still end up with this x to the power of 4. So there's actually lots of different functions of y that would give us this derivative. So we'll just write a few examples down. So we already had plus 10. We could have y equals 1/5 x to the power of 5 just as it is. We could have y equals 1/5 x to the power of 5 minus 27. It doesn't matter what it is, if regardless of that constant on the end, it's still going to give us this same derivative. So there's actually a family of curves that will all give us that derivative. And the way we write it is we write plus c on the end for plus a constant. So any number on the end, and it will still give us that same derivative. Now, unless we're given more information, we can't find that constant, so we will just leave it as that. Our second example asks us to find the primitive of 2x minus 5, all cubed. So that's our derivative that we've been given, so 2x minus 5 cubed, and we're going to find the original function. So the first thing we're going to do is increase that power by 1, so we'd have to the power of 4. Now, because of that power of 4, this would be the chain rule if we're going to differentiate it. So we have to do the reverse of it to get back to the original function. So in the chain rule, we would have multiplied by 4, which means in this one, we're going to divide by 4. And then the next step in the chain rule is that we would have multiplied by the derivative of the inside, which would have been 2. So undoing that, we're going to divide by 2, which means we're going to put a 2 down in the denominator with that 4. And the other thing we need to always remember is to add that constant on the end. So that's going to give us the whole family of curves that will give us this derivative. So we can just simplify that down. We'd have 2x minus 5 to the power of 4 over 8 plus c. The last example we have gives us a little bit more information. So this one asks us to find y as a function of x when our derivative is 6x squared plus 2x. And it also tells us that y is equal to 25 when x is equal to 2. So this extra piece of information is going to help us find that constant term, which is going to give us a specific function rather than a whole family of functions. So let's start off writing, we know that our derivative is 6x squared plus 2x. So finding the original function, we're going to increase the power by 1, so we've got a cubed here, and then we're going to divide by that power. The same thing here, we'll increase that power by 1 and divide by the power, and we've got our constant term on the end. So simplifying that down, 6 divided by 3 is 2x cubed, 2 divided by 2 will just leave us with x squared, plus c. So this is where we were stopping in our last examples, but because we have this extra information, we can actually figure out what that c is. So what we're going to do is substitute in these values. So we're going to have 25 equals 2 times 2 cubed plus 2 squared plus c. So 25 is equal to 16 plus 4 plus c, which means that 25 is equal to 20 plus c, and therefore c has to be equal to, 5. So that gives us a final answer of therefore y equals 2x cubed plus x squared plus 5. So that's an introduction to primitive functions.